Good morning. Thank you for being here. I'd like to thank Cincha for inviting me to speak today. My name is Michael, and really happy to see everyone showing up for this session. I know there's other great talks going on, but hopefully we'll see some maps come to life today in XJS. A little bit about myself before we begin. My name is Michael Giddens. I'm the CEO of Crestone Digital. We're a software development and consulting firm based in Denver. I've been working as a data scientist, open data and software development in the field for the last 17 years as both a developer and a solutions architect. I've been writing applications since EXTJS 3, and currently we normally do most of our applications in 6. And I'm really happy to see where Cincha's going with this conference. For the last decade, I've been working on both scientific and commercial applications, mainly in big data and the geospatial field. And I'm really excited today to share what we've been doing at Crestone, and we're bringing geospatial components directly into XJS now. And we'd like to share a little bit today of what those components look like and how they work. So Carto is a company and an open source geospatial and mapping product. All of their products, libraries, and codes are available on GitHub. Their database backend is Postgres with PostGIS, and their own library is added on top of that. Their business model comes in by providing software as a service, on-premise, even support installations, but they do provide the do-it-yourself open source solution as well. They also have free tiers in their SaaS service, so anyone can get started today by adding data and start building maps. Carto is a company that focuses on their stack and in turn works with companies like ours to work with clients that do not have development teams or expertise in location intelligence. Being that we love XJS and Carto, we felt that it was a great time to bring the two products together and really make some open source components. But now that we know what Carto is, what do they actually do? So on a high level, it is a bring your own data. Optionally, they have other things to mash up their demographic services and turn your data or address information into comprehensive and engaging data products. We'll take the data that you provided and generate rastered images or tiles, much like you would see with Google Maps, Bing, and other geospatial engines. The same data can also be exported in GeoJSON, shapefiles, CSV, and other useful formats. What really makes this platform powerful is that you have access to the SQL REST API. That means we can take any query and do basic filtering, geospatial, intersections, and more complex queries to really dig in and do data insights. Now, if we were just using the Carto platform and using their interface, there's a lot of wizards to create heat maps, bubble maps, time-lapse maps, and all those wonderful things. And even if you don't make maps right now, I would encourage you to go out and check out their blog and see what's trending right now in the geospatial world. It's estimated that by 2020, about 25 billion devices will be permanently connected and online, all which are generating location data. What business owners and decisioners need to know is what are the opportunities and things that need to be done to grow their business and make the right decisions. It's important. The people that are carrying around the phones are producing data. It's the tweets that people are creating. It's your social media interactions, your credit card transactions, and everything right now is being stored in a database somewhere. And in most cases, it's including the geospatial data of where it's happening. From what we've seen with our customers and talking with others, most companies are not really taking advantage of the information and geospatial information that's being created right now. So what we do as developers is kind of help build those data products and help these decision makers evaluate and understand this information. to look at that value in the information or data science field. With XJS and Carto combined, we think it's a great fit for these types of location intelligent applications. For the things we work on at Crustone, a lot of the data management systems, the generating reports, exploring data in various formats. So really adding the interactive maps has really become essential. What we call this new informative maps is really location intelligence and is an emerging field in the industry right now and is being led by Carto. Towards the end, I'll go through after we go through the components, we'll look at a sample project and see how we can do real-world projects with this type of mapping information. So map engines you see most often are Google Maps, Bing, along with other search engines. You probably even use them to find the hotel, check in, look for restaurants, driving directions for those that live close by. Maybe your company or government agency uses ArcGIS to visualize different layers. But really, viewing layers on a map is only good if you can ask it questions. These new XJS components will let you generate maps and put points, lines, and data on those maps. But I'm going to show you how we can use that same data to populate your grids, your data views, graphs, and really tie them all together. So business pressures, businesses are starting to get pressure about the decisions they make now in the world. And the world is becoming really more globally connected with the growing number of internet things coming online. And more users expect maps to be real-time and interactive. Data storage is becoming cheaper, and even governments are working towards sharing more open data and being more transparent. There are even market drivers that are pushing for location intelligence. We've seen a need for deeper knowledge on what drives customers and seeing that businesses are not taking full advantage of location insights. If we can limit our risks for that marketing department or our sales engineers, it'll help run a more efficient company. And as developers, while it's not our job to be an expert in all things, it is important to understand what they do in the business and hopefully build a product that best fits their needs. So as a map developer, it's important to know what type of limitations exist in building maps. Anyone that's worked with trying to put dots on Google Maps or other client-side markers knows that the performance of the application is kind of relative to the computer, to the memory, to even the browser that's taking place. While browsers continue to improve and XJS is getting more and more efficient for larger applications, that we still deal with limitations. So hopefully no one ever makes a map that has that many markers on a map. But if you do, you'll find out that there should be better ways to illustrate your information. When Google Maps started out, they really set a new standard for online mapping back in 2005. It truly was cutting edge. And typically, as a map developer, we call these slippy maps. But putting more than 1,000 markers on a map is really just too much. Fast forward 11 years, the browsers and computers have greatly increased. We're off of IE6, hopefully. And we're still finding that putting that many dots on a map can still be challenging, both from a UI standpoint and a computer standpoint. So most slippy maps use raster tiles. And these are 256 or 512 pixel images that come back and generated from the server in the cloud. And they're delivered to the browser so that you can get that kind of immersive experience, map experience. There's various base layers that a lot of companies provide, like satellite imagery and your more traditional road maps that you probably use every day. And all that information gets generated from data. And to give you an example, OpenStreetMap, one of the data sources out there, the raw file is 720 gigabytes of uncompressed XML data. It is 3.7 trillion points of interest throughout the world and around 375 million road segments that make up the world. And really generating tiles like that, let's see, I have that kind of data ahead of time, you really want to kind of pre-cache and pre-populate those using a lot of different servers. So all of that information is typically what we call base layers, and where Carto comes in is a way to generate live tiles from your data and overlay those on top of these base layers. Their servers do use content delivery networks and cache information for data that's not changing, and that gives us really good performance when working with large amounts of data. For databases up to about 10 million data points, Carto is really a great use case for live interactive maps, and we'll actually look at an example later on. When we get to projects that have more than 10 million data points, it's really best to understand what is needed and try to design and architect, or try to architect a hybrid between performance and data exploration. As you can see in this map here, in the last example, we kind of go beyond 10 million data points. And at a high zoom level on this, really, if you look at Paris, it only makes up about 10 by 10 pixels. So at this point, there's no really reason to look at millions of data points that exist in Paris at a high global level. So we can pre-cache some of these styles and maps at higher levels and then provide more interactivity at a lower zoom level, because we're not really looking at all the geospatial data at once. So I'd like to kind of show you some real-world use cases that are being used with Carto right now. In this project, Cache Atlas was developed with the Carto platform to provide a tool that can be used to advocate and promote considerations and appropriate use for cache transfer programs in humanitarian situations. The Cache Atlas is this one is an interactive global mapping tool aimed to visualize and represent cache transfer programs at a global level. This one, the next is an exploration of the busiest airports in the United States. The simple question led to another Carto partner, Cartographica, on a path of insights and analysis of airports and flights all around the globe. Using Carto, they developed a data-driven interactive visualization to derive insights on thousands of data points. Visonomy has been working on an interactive tool for climate risk called their Visonomy Climate Risk Terminal, which assesses flood risk and planning for sea level rising using real-time data and dynamic mapping. This one I like the most. With the access to more open data, Carto having their home base in New York City, we see a lot of interesting visualizations in that area. And one of them that I thought was interesting is how people are using their homes in New York City for rental property using Airbnb. This interactive map visualizes the median days needed to cover their rent. And in most cases, it's around 4 to 7 days that they can rent their place out to pay for their housing. And due to these studies, New York is actually creating new laws regulating New York residents from using their homes as rental property. And it's kind of a hot topic right now. You can see how one map can shed light on a controversial topic and get really people to start asking more informed questions. Finally, this is one from last year. It's a quick look on social data. In this case, it is visualizing all of the Twitter data that was created during the Super Bowl 50 and looking at categorical tweets of the teams and players. This was an interactive time-lapse map that shows the post-marketing analysis and how it can be used to see impacts and social trends. So all these components were not built in XJS, and it started to become a problem for us when we want to bring Carto into our customers' applications. So we decided to change that, and today we're actually happy to introduce a suite of XJS components that will allow you to make maps as easily as this directly in So we've been working on these components for the last few months now and testing them in real-world projects that we work on. We are partnering with Carto, the company, and these will be the official Carto components that will stay open source and continue to be improved and supported. It is our hope that you'll be excited about these and help us provide feedback and direction on how we can do even more in both our applications and yours. At this, we're happy to introduce CartoMap component, the proxy and store. These allow you to easily connect with the Carto tables in XJS 6. It supports all the MVVM style development and binding to give you that feel of other XJS components. All of this is located on GitHub, and we do have a variety of examples that we have now and are continuing to add more as we progress with this library. So these components integrate natively into XJS and work directly with filters, sorters, grids, panels, combo boxes, charts, data views, even paging toolbars. Basically anything that is using a store can work with the Carto store. There's even a few extra things that our components do to leverage your Carto tables. We'll look at those in a bit. So let's dive into some code and kind of get a little technical and see how it all works. Let's start with the simplest of the component and build up from there. So if we just wanted to put a map, a base layer onto your components or your application, to do this, we only need to really include the Carto library and provide the X type of CartoMap. And this will use all the default settings that we've provided and show a map that fits and layout to any normal XJS component. So pretty easy. Now I know that's not very exciting, it's just a base layer, but it's a great start. And maybe you have some other information where you'd want to zoom into a certain area to show the relevance and where that information's at. Carto provides a choice of many predefined base layers to choose from. And it's easy to set the base map from a predefined list. Now, if you have your own base layers or use third-party libraries like Mapbox, if you're more familiar with those services, you can easily set those up by using the object notation and providing the URL template and the attribution. Now, the starting location on a map is also important when setting up your map. To do that, we have two attributes called the center and default map zone. We have two ways of binding a starting center point. The first is by using the ISO 3166 country codes, and you can just set the text value to that. The second is the lat-long array notation format. The map zoom tells at which level the map should be rendered. So for those not familiar with zoom levels, a zoom level 0 is typically your global level at the world and can go down to about zoom level 18, which is more your street level view. And both of these are bindable, so it's great if you have combo boxes of countries and preferred zoom levels to kind of interact with your components. So now that we have a map, let's try to actually start using Carto tables and putting your data onto that map. And to do this, we have a property called layers. And layers is much like components have items. This can accept a list of arrays, each representing a layer on the map. Carto's a little special when it comes to traditional map layers, and they have something called sublayers. And what makes these sublayers different is that in traditional layers, there's just a single layer, but when dealing with Carto, you can take a bunch of your data layers, each having different queries, different settings, and it will compile those server-side and produce one tile layer that comes back. So if you had 5 data layers, you're not producing 5 times the number of tiles, which can be really expensive when transmitting that information. So when setting up a base layer, we need to provide a store. And this assumes that we are using our Carto store And currently right now, these stores only work with the Carto store and no other XJS stores. In that store, we need to define two values in our Carto proxy. And one is the username. So we put in our account name and then the table that we're interested in binding that map to. So by default, you'll see a bunch of orange dots, and that is something we can also change. So let's take a look and see what that looks like. So we've just bound to the viewport, and so you'll see a base layer and the Slippy map here, and this is the table with all of the data points on the map. So I can zoom in and out, and I was able to do that in just a few lines of code. So at this point, we can load data as quickly as that in your project in just a matter of minutes and add a map. But really, we want to do more with that. So in the next example, we're adding a few more things to the example and hooking up a grid to that sublayer store. So if we go back to the demos. So you'll see here a few things have been introduced. The first, we have what we call the Carto CSS. And that is a language that was created by the Mapbox company that creates styles for rastered tiles. And it's a very versatile library. As the name suggests, it's similar to CSS and allows you to add cascading rules to your data server side before it gets rendered. And we've also changed the base layer on this map, and we're using a dark one. If we hover over, you'll see that there is also a tooltip. And even though that we're returning tiles for these actual images that represent the points, we're making a secondary JSON request, which returns a hash key, and it actually maps that hash key to every pixel on that tile. So as you mouse over, it'll actually retrieve the data fields from that tile and then fire off an onHover event and onHover out, depending on which markers you're on top of. So let's see what this new code looks like to get this working. Oops. Okay, so what you see in green are the new additions. Hopefully everybody can see that from the back. On the left, you'll see that we set the selection to be bindable. To make the base layer dark, we changed that to use the dark matter base layer that's provided by Carto. To enable the heat map style, we have a few new predefined types already set up in the library, and one of those in this example is intensity. This takes the markers and overlays them much like a multiplicity thing you would see in Photoshop. And there's a lot of other variations of types of overlays that you can do. We then bind the sublayer to the layer store, and stores using the default bind property. So similar to a grid, if you bind config is giving a string, the sublayer assumes that it is also referencing the store. The layer store is defined in the viewModel store config. It is a Carto store, and its proxy is given the necessary username and table to connect to the data. And finally, for the mouse overs and tooltips, we have to enable the interactivity settings. And by setting that to true, it'll activate the listeners for an on-click, on-hover, and on-hover out of every marker on the map. Setting the tooltip enables the setting the tooltip to true will actually enable the on-hover to pop up the map. And the interactivity also tells which fields to pull from the table to reduce the amount of overhead. So if you have a lot of columns or some of your columns have a lot of data, you can limit the amount of data coming back for your tooltips. Now with the grid panel over on the right, it should look very familiar if you make grid panels. We just bind the selection to the same selected value, as well as the store to the layer store. Since selection is two-way bindable on both the grid and the map, selecting one sets the selection on the other and vice versa. You'll see in the grid column model now that we have the store attached to the map sublayer. You can point the data indexes to all of your columns to point to those fields. And as simple as that, we have a map and a grid all coming from the same data source. So let's do a few more, some more binding of map components and kind of go backwards now. So in this example, we're going to not show the data on the map. So in return, we're still loading the data from the maps store, but now we have a component on the right with an X template. And really what we want to do is, as we select on a different record, we want to move the map to that location and zoom in to that area. And it's also showing all the details on the right. So let's see how this works. So going off of what we learned so far, we added a few new things. The first is a selected actions property, which takes an array of values that defines how the map behaves when the map is selected value changes. And so in that past example you saw, we added the pan to and place marker attributions. We then bind the layer store in the view model for the map, grid, and X template, all to point to the same layer. Finally, we had to activate the enable lat long property in the proxy, and this actually goes out to the database and makes sure that the lat long is being returned for every point of interest so that it can pass that information on to the selected actions. So adding onto those features and building blocks of these components is the ability to automatically filter the store based on the extents of your viewport and your map. We have a quick little demo to show how this works. So if I turn off the lock to map, you'll see that it's much like the earlier examples. I have a map, I have my data points, and then I have my grid bound to the data. And now by turning on the lock to map, we've actually bound this store to enable the extents. So now as I move around, you'll see that the grid panel is automatically updating its data as we zoom in and out and pan. So very simple, but very useful in a lot of applications, and you'll see in our final example how that all ties together. So what do we have to do to get that to work? So not much. So in our view model, we actually add a store ID so that we can reference this later in the map. We also had a reference to the combo box to bind that value of the map lock property. By enabling and disabling the map lock property, will tell the stores whether or not to add the bounding box to the proxy's requests and the queries that are actually happening behind the scenes. The other new property is the stores to lock array. This is what registers to the map locks to dispatch the updates to all the stores that are in that array. So by adding and removing stores to the property will allow you as a developer to give control over which stores are actually being updated when the map moves. So the great thing about the component is we've developed this so that you never actually have to use a map, even if you have all your data stored in Carto. So Carto is designed as a RESTful API, And the whole time we've just been obfuscating the SQL behind the scenes in the proxy to actually retrieve that data and then map that back to the store fields. So by using a store directly or in a view model, like shown in the past examples, we can easily set this up to work with grid panels, data views, charts, and again, really anything that associates to a store. It also works great with your native sorters, filters, limits, paging, and all the normal grid plugins that you would use. We have added a new group by value, which turns your normal fields store into an aggregation feature. And it's, really powerful for generating statistics. So any Postgres stat aggregation that you may want to use will work in this feature. Additionally, filters and limits can be applied to the group bys so that you can even do sub-selections off of those. And finally, we have 2 unique flags that repurpose the store to retrieve a list of tables from your Carto account and a list of column fields from a table. We do that by setting the mode to either tables or columns to make that happen. We also have the options to aggregate the data and have examples on GitHub of how to make use of this. But basically, you can call an add group by field, and you would set the property value, which is one of your columns in your database, then the name of the field that you would like it to be called when it returns to map to either your grid panel or something else, and then the aggregation type. So you can set the value to be an average, a count, standard deviation, min, max, really anything that is a statistical function. So we've put together a little kitchen sink to let us explore your Carto account and data to see how it really all works together. In this examples, we can explore the tables and filters, bind to the viewport, and edit the CSS or the Carto CSS. And we can take a quick look and see how that works. So in this example, this is also available on the GitHub examples. So if you do have a Carto account or interested in trying this out, you can just put in your Carto name. And as I mentioned earlier, this will retrieve, this combo box retrieves a list of tables. And so in this case, I'd like to look at tweets from Star Wars. So as soon as I do that, we actually did a few things behind the scenes. And what we did is we actually got a list of field names from that table and populated all of these combo boxes. We're actually using the same store and referencing all of those as one. We then also took that same list and generated a list of dynamically created filters based on those fields. And each one of these filters is an aggregate drop-down or a facet of those so that we can actually start applying filters from that data. Now we have the Carto CSS, which is some default CSS, and then you can go in and actually change that. We do have documentation on more of how that language is written. And then we have some statistics. So in this case, the tweets, we'd like to maybe pick a column and go by gender to see how many tweets of Star Wars are female or male or not available. So by doing this, we've actually done the aggregate to the sublayers map store and applied that to that particular field. And it's going to go ahead and render in real time this updated information. Now I can go ahead and add in other information, so I can see the sum of followers for males and females. I can then go in and click on the average, min, max, and this is just one example of some of the statistical features that are available. And we can even go in and show how we had a pre-populated list of all the Carto tables and pick one that's really nice. Let's see. We'll just go back to that dark theme. So you'll see this yellow one. We actually did some formulas and post-work client side to calculate some standard deviations and quickly show some outliers. What's really great is we can then go in and I can't really see. Which one's the sentiment? This one? Yeah. So if I just wanted to look at positive sentiments. So it's actually going to go in and update the map and say only look at positive and negative. I go ahead and click this off. So I'm just using a regular combo box pills or tags combo box. And so this is just using regular filters. We're not doing anything different than you would normally do in your applications. All the magic's happening with the proxy, with the store, and it's all happening behind the scenes. So it's really great. And the nice part is we take this off. We can then go ahead and turn on the, does this one not have the lock? No. But as I add these filters to the sentiment, you'll see if I go back to the statistics, all of this information is getting updated. Now, if I wanted to bound to the view box, I can then click there and then zoom in. And again, you'll see the standard deviations are getting updated, the statistics are getting updated. I can go in and go ahead and reclassify by a different attribute, the columns. Oh, sorry, I don't see some, oh, because it's not a numerical column. So yeah, this is the kitchen sink. So you can go in and play with your own data and kind of explore your information quickly and kind of gain some insights. So I have a RealWorld project or a nice demo. So finally, I'd like to show you this more real-world project that you might see are being used. In this example, we've tried to make use of all the different features that I've shown today and really build a more complex project. In this example, we've loaded, designed, and actually built this application in just over a day by one developer. So what we did is we went and found some open data, and this is the federal fire occurrences for the last 30 years that have taken place in the United States. And this is almost 700,000 data points being rendered on a map. So again, all of this stuff is not actually client-side. These tiles are being generated server-side as we move around on the map. We can change the Carto CSS styling by going from a single color to doing more logical. And in this case, we've actually separated out the natural fires to human-generated fires. And quickly we can see just by doing that one simple modification that most of the natural wildfires take place on the western side of the United States and almost none on the eastern. We have a data view that is showing attached to a grouper store or a group by store to show the facets of natural versus human. We have some statistics that we've set up. So we actually did a group by of the years of all 700,000 data points. And we are also doing standard deviation coloring client side on this smaller data set or this aggregated data set to show any outliers that may actually give you some insight into your information. So in this case, we're actually looking at the acres of fires that actually did damage in each year. We can switch that easy to do the facet to count and do the standard deviation on the number of fires. We'll go back to the acres. And then finally, we have some filters. So in this case, we have, again, similar to the previous one, I would like to pick Colorado since that's where we're based out of. Is that Colorado? Yeah. And so what it's actually doing is applying that filter to the sublayer store. And that filter is then triggering the map that it has changed, and it'll actually go re-render and fetch those tiles from the Carto server. And so we can mix and match as many filters as we want. If we wanted to go ahead and turn on California. And again, you'll see it'll take a slight pause, but it's actually going out, doing those calculations, the styling rendering, and then returning those results. So again, we can switch back and render the different styles. Maybe the demo gods are happy. Is this California? The demo gods are not happy. Please. There we go. Let's get back to cause. And so now I'm kind of seeing what's actually taking place in Colorado. Now, if I go back to my statistics, what I see immediately is there's 2 outliers, and we're using 3-step standard deviations to look at this information, and red being actually 3 steps. So for me, not really knowing the history of Colorado wildfires, and again, not really knowing what data insights that are in this data, just by playing around, I was able to spot 2 outliers of interest. Now, I went over to Wikipedia, and I searched for the list of Colorado wildfires, and what I found out is that in 2002, there was the Hayman fire in the National Forest that did a tremendous amount of damage, burned down a lot of houses. It was just a really horrible fire. And then again in 2012, the Waldo Canyon fire was another major one. So again, just by exploring the data, I was able to really kind of get some insights. And at this point, I could turn on my lock to viewport. And then again, as I move around, we'll see that this data is getting updated. Again, looking at thousands and thousands of data points in real time. I could have turned on tooltips and maybe tried to get more information about each one of these individual files, but for this example, I think I was really just trying to show how you can quickly get some data insights from just one day hack of putting a project together. So the library is available on GitHub. It is open source and free for anyone to use. If you're interested in our work or would like to contribute, please get in touch with me. And that's really all I have. So if you have any questions, I'd love to hear them. Yes?
Yeah, it looks to me that these Carto components are heavily connected with your service.
They are strictly focused on the Carto platform, much like the D3 adapters focus strictly on the D3 components. There's really not many companies actually providing this kind of real-time data mapping services. And we use both products a lot when working with our customers. And really, we kept making the same things over again and really decided to build that adapter so that we can use it. And since we were making it for ourselves, we thought it'd be appropriate to make that open source for others to use.
Yeah, so I saw that when you're accessing your data on the, I mean, client is accessing the data on the Carto services.
Yes.
They need to provide the username?
Yes.
So how do you protect that?
So if you're looking to provide internal private data, certain people have on-premise installation, so you can do it in your intranet, things like that. There are also ways to use proxies so that if you have your OAuth or your two-factor authentication, you can go through your own proxies to route that traffic. Anyone else? Well, thank you again for your time.